Hi everybody.
Hi, Charlie.
Thank you. Good afternoon. So today we'll be talking about auto layout fundamentals or fundamentals of auto layout. So this is I don't know, as everybody knows, or maybe not everybody. I just picked up iOS a couple of months ago, and this was one of the things I don't want to use the word defeat, but that's the term. I had to defeat it to an extent, anyways. So today we'll just be looking at a few of the things I learned along the way. Firstly, what is auto layout? So I think a simple way to explain this would be to use web development. We do Android development, iOS, and we know that one thing common with all these type of developments is the fact that you deal with user interfaces, and you have to, one way or the other, arrange those interfaces such that it brings something that looks nice that a user can see and appreciate. So auto layout is one of the ways you can build your user interface in iOS, and it is a constraint-based layout system. So it allows us to build interfaces that are adaptive. And when I say adaptive, it means that when you're using that UI on a small screen or on a bigger screen, it does not distort. It just gives you the normal design it ought to do. So auto layout helps us do this. And how does that happen? So what auto layout does is it dynamically calculates the size and the position of all of your views. I remember that I said it uses constraints. So based on the constraints you set, auto layout does a calculation and then decides that, okay, this button should be on this point of your mobile device or on the other point. So would be looking at what all these guys actually mean later on in the talk. But first of all, we should know why auto layout is such a darling, why you want to learn auto layout. So firstly, we'll be going through some of the ways that layouts are built in iOS. So, and when I say building layout, it just means positioning a view. You want to, and a view can be anything. It could be a button, it could be a label. I'm sure we're familiar with all these things. So you want to put that particular view somewhere on your mobile device. So to position a view, there are three ways that can happen in iOS. The first, okay, so not now, it's probably not three again because of the introduction of Swift UI. But before Swift UI was introduced, there were three ways to position a view in iOS, and those ways are setting the frame of the view, adding dynamism with auto resizing masks, and the third one is auto layout. So I'd like to do a quick explanation of how views are rendered on a mobile device. So looking at this diagram that we have here, we can see two rectangles. So we just assume that we want to position, so let's call these rectangles buttons. So we want to position two buttons on our iPhone. This is our iPhone. So we're positioning two buttons there. So it happens that when you place a button on a mobile phone, the mobile phone uses the X and Y coordinates that we're familiar with. So, but in the case of mobile phones, different from the mathematical coordinates we know. You know, in the mathematical coordinates, you have like a cross, and then at the point where those two lines meet, you have your 0, 0 here. So, but for um, mobile phones, I think it's the same in Android too. I'll just say for mobile devices generally, your origin is at this point, 0, 0. Then if you keep going downwards, your X reduces, and if you keep going horizontally, your Y increases. Your X increases, Y increases, stuff like that. So looking at these two positioning, we can see here that this is at position 20, 20. And then the height of the button is 80, the width of the button is 120. So this just basically breaks down how positioning is done. You have a point, that's a coordinate point. You have an height for your button. In this case, you have a width for your button. So you just look at your mobile device and decide that, okay, I want to put it at position 20, 20, or I want to put it at position 20, 40, which will probably be somewhere around here. So that is how positionings occur. Using these three positioning tricks, at the basis of everything, this is what happens. What happens at the end of the day is that you are putting it at a certain coordinate in your device. Okay, so we're going to look at each of the ways we mentioned and see, so that it will help understand how auto layout performs well. So to set the frame of a view, we know what a frame is. Let's assume that this TV here is a view. The frame is just this guy, the bounce, something like that. So to set the frame of a view is a rectangle with origin. I explained that you have an origin. You have the XY coordinates in terms of your X in terms of height, your Y in terms of width. So that is the frame of a view. Now, if you want to build, sorry, let's go back here. So if you want to build a mobile application and you want to build your layout using this method, setting the frame of the view, it means that for every view you have to calculate the X and Y coordinates. You have to know where exactly on the phone you want your button to stay. It means that at the end of the day, by the time I write so this is done programmatically. It means that at the end of the day, by the time I write my code, I have a part of the code saying my button should be at position 30, 50. My label should be at position 2, 5, something like that. So now this can be a good thing, and then it can be a bad thing on the other side. So we'll look at the pros and cons of frame setting. So for when you're using frame setting, what happens is that you have like specific control of how you want to put your views. It means that when you want something to change, you can specify exactly where on the phone you want that view to be. It's very easy to do. You just specify that, okay, well, when so happens, my button should move from position 30, 50 to position 45, something. So you can specifically state what you want. It means that at every point in time, you know how your UI will look like. And then it also provides the most flexibility and power. I mean, for you to be able to tell your button to stay at this point when something happens, you have enough power. Now, but then this presents a con in the sense that you have to set frame for every view you have. Now, looking at most of the applications we have today, so let's just assume that say something like a messaging app. So it means that I have to tell my iPhone that, okay, for the new, when you want to click on, for the button that gives you a new message, it has to be on position 30, 50. For the button that will show you the message itself, it has to be on position kiniko. So it means I just have to keep, I knew what I was going to do. Yeah, so it means I just have to keep setting frame for every type of view that I can have, which, as you know, can be voluminous, because if you have an app that has lots of views, it means you set lots of frame. So that will give you plenty code to write. And then another thing is lack of flexibility and dynamism, in the sense that in that case, now assume that your user now decides to change the orientation of your application, and you have told this phone that, okay, this button should be at position 30, 50. You can imagine what will happen. Everything will scatter. So another thing is it gives complexity. When you have lots of code dealing with changing frame, you realize that it becomes more complex. So the idea is as much as possible to avoid frame-based layouts if it is possible. So there are some cases where you necessarily have to use this. Maybe there's a reason you have to use it, you can, but if it is possible for you to go around it, then it is advised to do so. So the second method is dynamism with auto-resizing mask. So now, what auto-resizing mask is I think we know what bit mask is in all these bitwise operators, something like that. So it's exactly bitwise operators, doing or XOR, stuff like yeah. So that's the concept behind the auto-resizing mask. It's an integer bit mask, and what it does is that it allows the view to resize itself when the super view changes. Now, what we call super view is taking this television as a view now. Let's assume that this my slide is a button. It's centered in this television. My TV is the super view, and this guy is the view I'm talking about. So when my super view changes, maybe I turn it this way, it means that it finds a way to resize it. So the default is that for every view in iOS, there's an auto-resizing mask by default. Now, if you are going to use auto-resizing mask, this is an example of how you set. So this is an example of how you set your auto-resizing mask to change. It's actually easy to use, but as usual, it has its own pros and cons. So let's look at that. So the pros for using auto-resizing mask is that it adds flexibility and dynamism. So in this case, you can actually, when your screen orientation changes, it actually works fine. It does. And then it simplifies the creation of layouts that adapt to external changes. So from this second pro is where the con comes from. I'd just like to explain so there are two types of changes that can happen. We have external changes and we have internal changes. So external changes are those changes that can occur based on user performance. Say maybe when the user changes the screen orientation, or maybe the screen size is different as an external change. Or maybe when there's this thing that happens on Android where you can reduce the size of the app. That's also an external change. And then internal changes, an example of an internal change is when, say, the content of your app changes. So like in most of the apps we deal with here, say insurance app, and then someone sends you a lot of data. So obviously it will change. If you're having, say, a rectangle that displays data of height 10 before, and then someone sends times 10 of that, it becomes height 100. So that is an example of internal change. So what happens when you use auto resizing mask is that if an internal change occurs, it doesn't adapt to that. So it only works for external changes. So then we move on to auto layout. So what it does is that auto layout does not deal with the two methods I mentioned previously, especially the frame-based, basically with the frame. But for auto layouts, it deals with constraints. It doesn't deal with frames. Now, when I say it deals with constraints, it means that it takes the relationship between two views. You realize that if you have two views, just looking at it, maybe not this discussion we're having, just looking at it on a normal day, if you have two views, you know that there's a particular amount of space between those views. You know that maybe button B is to the right of button A, or button B is underneath button A. There's a relationship, so to speak. So what auto layout does is it deals with the relationship, and it does that using what we call constraints. Then it also results to a flexible and dynamic layout. So what happens is, as a developer using auto layout, what you do is you define constraints between your views. You have two buttons, button A and button B. So you define the constraint you want, maybe that button to the right, something like that. You define the constraint. And then what happens is that at runtime, the constraints are inspected. Then, after inspection, what the system does is to calculate the frames. Now we're going back to frames that we started with, but in this case, I as a developer, I'm not dealing with the frames. The system has to deal with it and all that. So now, if at that same point, I rotate my screen, what happens is that the system detects a change and then it calculates the constraint again and does the framing again. So we have pros of auto layout and we have cons as well. So for auto layout, it's descriptive, flexible, it is dynamic. But the cons, and this I faced, is that debugging is hard. So when you have an issue, especially using Xcode, when you have an issue with auto layout, you probably don't even know where it is coming from. And then the suggestions made, if you check them out, you're like, okay, what's going on? It's tough. And also one tough thing to work with when using auto layout is pro views. It's crazy, but then there are ways. So when you master auto layout, you tend to realize that these things are not necessarily cons. You just have to know how to use the tool. So that was just giving us an overview of those three methods. So we talk about what constraints are. So like I mentioned earlier, constraints are basically what auto layout uses. That's what it used to perform on its magic. And then constraint help to define relationship between two items. So looking at this image that we have here, we have two buttons. We have a blue button and a red button. And then we can see there's a distance between these two buttons, 8 centimeters, something like that. So now, if I'm going to set a constraint to these buttons, what I do is, my red button is the red view, mind you, and my blue button is the blue view. So what I do is red view leading. Leading means the beginning of the red view. So the space before my red view equals to 1 times blue view trailing. Trailing is the end. So 1 times blue view trailing plus 8. So you can see that trailing is end, something at the back, something like that. So trailing of this blue view is this part. Leading of this red view is this part. So I want to get the space that ought to be here. And what I'm saying is that from this place, plus 8 is where this guy should start from. So that is basically how constraints and auto layout work. Once you specify the constraints to the device, it just does a simple linear calculation, linear equation, and gets the spacing and the positioning of the view. So in this way, you don't necessarily have to deal with framing. You don't necessarily have to deal with the fact that, okay, my user rotates the screen, then it means that I have a larger width and a smaller height. It means that all those positioning will change. You don't necessarily have to do that. The system handles everything for you. So one thing that is very popular, or for me anyways, I would say since I started using auto layout, it's like something I cannot do without. So stack views make your work easy. It makes life easy for you. Like the name implies, a stack. We know what stacks are. You're just putting something on top of something or beside. So in iOS, we have, for stack views, we have 2 types of stack views. We have the vertical stack view, where views are stacked vertically. And then we have the horizontal stack view, where views, of course, are stacked horizontally. Yeah, so when using stack view, it gives you a degree of control on how your views are laid out. When you are using stack views, at least in the stack view, you don't necessarily have to think of constraints. So, and then it is always advisable to use stack views before resorting to constraint. So most times when you have your views, you realize that they are probably arranged vertically or horizontally, one way or the other. You probably can manipulate it such that your stack views will work. You can have nested stack views, so you can have an horizontal stack view inside a vertical stack view. That way you can arrange anyhow you want. So this is how horizontal stack views go. And then we have the vertical and horizontal. Okay, so when I was taking this course from Udacity, I got to know about the guiding principles and then commandment of auto layout. Now, if these principles are not followed, or the guidelines, the commandments, if they are not followed, you might scale through. But most times, it is just nice to, as much as possible, try to follow it so that you don't get in trouble. So, and I'll cite an example. So, some few weeks ago, I worked on a UI for the project I was working on. Worked on a UI and did it, and it was nice. Like, it looked okay. So then last week I started working on integrations and actually putting data inside the UI. So I was dealing with a scroll view anyways, and in the scroll view there was a button and a couple of stack views. So when I did it initially, I could see my button, I could scroll and see my button, and everything was perfect until I did the integration, and then the button was ideal somewhere, right? I'll just scroll up and it will just get to a point and stop. No button, nothing, nothing. What's going on now? So apparently it was just one little constraint that I did not make. I did not set the height of the scroll view, so it was just doing anyhow I wanted. So it's nice to follow these principles if you're looking into picking up iOS or for any reason you just want to know how auto layout works. Try following this principle. The first thing is that stack views first and then constraints later. Like I mentioned, it is easier for you to work with stack views. I mean, you can just put your views on top of each other and then say, okay, all of you should have padding of 5 centimeters or something. It's easier that way. And then another principle is to start small. If you're not starting small, don't start at all because by the time you keep on, everything will get scattered. So especially when you're working on a big project, there are times when after arranging the views, you don't even know what's next. You're like, which one should I pick next? Should I do this or should I do that? So, but then it's always easy to start small and ensure that you are working from the inside out. So what I mean by working from the inside out is just pick the innermost view, work with it, and then put it inside a view that's supposed to be outside it, and then like that, like that. So it's easier that way because when you get the smaller area, you can get what I'm saying. You can then get the larger one, something like that. So this one, this number 4 is very important. You should trust only your simulator or your device. Don't trust Xcode's preview because you will probably think that what you've done doesn't work until you run it on a simulator and you realize that it's actually well aligned. So whenever you change anything, you change any constraints, always make sure that you run it on your device or your simulator. That is the only thing that will tell you if what you've done is actually right or wrong. And then the last thing is don't panic. Don't panic because there's always a way around whatever it is that is going on. If your button is missing inside scroll view, there's something that is wrong. You just have to figure it out. So, and then the commandments of so the first thing is since you are using stack view, before you even think of going to using constraints, each stack view, the horizontal, the vertical, they all have properties. They have properties like maybe spacing between the views inside the stack view. So you can decide to tweak the properties of your stack view. If that does not work for you, use another stack view in the sense that you can decide that you want to put a vertical stack view inside an horizontal stack view that is inside a vertical stack view. It all just try manipulating your views with the stack view. Then this third commandment that says tweak the compression resistance or organ priority. So compression resistance and organ priority are two should I call them concepts in so for each view they have compression resistance. Compression resistance in the sense that I don't want to be compressed, just like the name says, and then organ priority. Do I want to enlarge? Something like that. So you can, if you are putting two views beside each other, there are times that one view will grow more than the other one. Say maybe you have two buttons beside each other, and then in one of the buttons it says calculate quotes, and the other button says save. Obviously, one of them has more content than the other one. So if your save button is growing larger and your calculate code button is growing smaller, you realize that you'll not be able to see the text inside that. So with the compression resistance and organ priority, you can find a way around that. Then the next step is to add constraints to the stack view. So it means that at the end of the day, you'll probably not be able to run away from making constraints. But at least this time around, it means that you've arranged your views inside the stack view. And then you can use the stack view to add constraints to its own super view. Then a couple more constraints. And the last thing is that if everything fails, use a filler view. A filler view, we've used a couple of that in the project we do here. You're just putting just an empty view and you're probably using it to separate something or the other. So these are the references. If you want to check out auto layout, you can go to any of these places, or better still, go to Udacity and take their auto layout course. So thank you very much.
You said you should prioritize Spark views over the auto layout.
Did I say that?
You said Spark view
Over constraints, no. Over constraint. Start views first, constraints layout. Constraints later. So they are all still under auto layout. Thank you. Okay, thank you. Thank you. So I saw, okay, I think I'll just drop I saw a couple of slide things and everything. Well, I had to choose one. Yeah, I think I'll drop out. Yes, I'll do that. Thank you.